Nextreme Thermoelectric Chiller for Biotech Research. Modern microscopy equipment used for biotechnology research enables visualization, measurement, and analysis of cells, tissues, and other biological specimens. Digital microscopes utilizing CCD, charge-coupled device, or CMOS sensor-based cameras need to maintain very precise temperature control to provide high-resolution images and ensure long-life operation of the device. Due to heat generated by the power source and other internal components, proper cooling is required to ensure maximum performance. In optical microscopes, light travels through a lens to enable a magnified view of a sample. Digital microscopes utilize a CCD or CMOS sensor-based camera to focus on a sample and display the image on a computer screen. Because high temperatures increase thermal noise and negatively affect image resolution, CCD or CMOS sensors need to be kept below ambient, depending on the type of microscope. A refrigeration system will most likely be required to dissipate waste heat and cool the sensor cold plate to below 18 degrees C. A thermoelectric cooler may also be needed in between the cold plate and imaging sensor to cool well below freezing. This isn't possible with passive cooling technologies like liquid heat exchangers that only provide cooling slightly above ambient temperatures. The miniaturization of camera devices increases heat flux density, making thermal management even more challenging. Recirculating chillers are used to route heat away from sensitive electronics and efficiently dissipate it into the surrounding environment. Imaging sensors also need to maintain stable temperature control to within plus or minus 0.5 degrees C to assure very high-resolution images are captured. Laboratory technicians continue searching for cooling solutions providing low noise and vibration. While traditional compressor-based systems tend to vibrate and are often noisy, thermoelectric chillers utilize smaller fans and pumps resulting in less noise and vibration. Any object that goes below dew point will condense from moisture in the air. It is important to protect sensitive optoelectronics by insulating all surfaces that go below dew point. Sometimes this can be challenging with outgassing from insulation, causing contamination to optical components. Vacuum sealing optoelectronic packages are used to protect sensitive electronics. In addition, government environmental regulations are motivating laboratories to replace traditional hydrofluorocarbon (HFC) refrigerants with more environmentally friendly options that have low global warming potential. Thermoelectric-based chillers provide zero global warming potential. With the ability to cool well below ambient temperatures, recirculating thermoelectric chillers are a better option than passive solutions, such as heat sinks and fans or ambient liquid cooling systems. Their plug-and-play design provides quick and easy installation in any laboratory environment. Recirculating chillers can also be used in combination with a thermoelectric cooler to reduce thermal noise and ensure maximum image resolution. This illustration shows how heat from the microscope camera is absorbed via a liquid coolant that is circulated by the liquid-to-air engine in the thermoelectric chiller. The chiller cools the temperature of the coolant circuit while exhausting waste heat into the ambient environment. A thermoelectric cooler is soldered to a cold plate inside the camera to further cool down the CCD or CMOS sensor housing to minus 20 or minus 30 degrees C, depending on the required image resolution. A recirculating chiller can be designed to cool other critical optoelectronic components, such as detectors and FPGAs. Laird Thermal Systems' Nextreme NRC400 Thermoelectric Chiller delivers precise temperature control stability to within plus or minus 0.05 degrees C under steady-state conditions for modern microscopy equipment. Utilizing next-generation thermoelectric coolers and high-performance heat exchanger technology, the unit delivers 400 watts of cooling capacity. Compared to previous versions, the NRC400 offers lower noise operation and a higher coefficient of performance. Solid-state thermoelectric technology provides fewer moving parts, extending the product lifetime and requiring minimal maintenance, reducing the overall operating costs. Users can easily control temperature set points and alarm features via an intuitive LCD touch screen display. The NRC400 is a semi-closed system featuring a larger reservoir tank requiring less refilling during operation and improved temperature stability. The NRC400 is approved by UL for laboratory use per UL 61010-1, has CE marking, and is RoHS compliant. Thermoelectric-based chillers are environmentally friendly, as no harmful HFC refrigerants are used, resulting in zero global warming potential. The unit operates on a universal power supply, making it easy to source one part number for global use. Digital microscopes utilize CCD or CMOS sensor-based cameras to capture high-resolution images of microstructures. A thermal solution is required to remove waste heat and maintain very precise temperature control of imaging sensors. Thermoelectric chillers, in combination with thermoelectric coolers, minimize thermal noise in imaging sensors to achieve maximum image resolution. Utilizing next-generation thermoelectric coolers, the NRC400 Performance Chiller delivers 400 watts of cooling power and a temperature stability of plus or minus 0.05 degrees C, which exceeds requirements for microscopy imaging applications. Visit LairdThermal.com to learn more about thermal management for digital microscopes. Laird Thermal Systems develops thermal management solutions for demanding applications within medical, analytical, industrial, transportation, and telecom markets. If you have questions or need more information, please chat with us via the website at LairdThermal.com.